Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about the rules of IUPAC nomenclature for alkanes, as well as we have also did the IUPAC nomenclature for the structure that was being provided to us. And now we are going to do the structure of the IUPAC name that has been provided to us, and the IUPAC name is of alkane. So how to draw the structural formula of the IUPAC name provided to us? Let us talk about that. So this is the IUPAC name that has been provided to us, and from this we have to make the that is structural formula of the IUPAC name that has been provided to us. So now in this case, how to name it? First of all, we have to observe the parent hydrocarbon, and in this case the parent hydrocarbon will be at the last one. Just like a person has a surname and surname comes at the last, so similarly the parent hydrocarbon represents the total number of carbon atoms that are present in a continuous chain form. So now in this case the suffix of this whole IUPAC name is basically ending with decane. So since it is ending with decane, so therefore it will have basically 10 electrons in a continuous chain format. So let us draw that. So because it has a parent hydrocarbon known as decane, so for that we will write in this way. That is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these are the 10 carbon atoms that are present in a continuous chain. And this will be the longest form, because as the IUPAC name that we have studied, and we have also studied the rules of IUPAC, in which the parent hydrocarbon represents the longest continuous chain, and this is what we have made, that the decane is now being the longest continuous chain. So now let us see that what are the substituents that are being attached towards this hydrocarbon, this parent hydrocarbon. And meanwhile I have not preferred to write the hydrogen here, because first of all the thing that I have to do is I will fill the substituent first, and then I'll see the valency, that how much the valency of the carbon is and how much hydrogen is to be filled. So for that let me see this one again. So it has basically 3,3 dimethyl. As you could see that this is a substituent that we have, that is at position number 3, and again at position number 3, and I could see that again at position number 5 also there is an substituent, but the substituent that is attached on the position number 5th, or the 5th carbon atom, is nothing but ethyl butyl, or we could say that is 2-ethyl butyl. So how can we write this 2-ethyl butyl? This is very much simple to understand. So first of all, what we are going to do, we are going to do the side chain. We are going to draw the structure of the side chain, and let us see that this would be attached towards the parent hydrocarbon. So now therefore the side chain, it consists of basically ethyl butyl. It is nothing but 2-ethyl butyl, and it ends with butyl, or the parent name of this side chain is ending with butyl. So therefore it would contain basically 4 carbon atoms in a straight chain. So therefore this is the thing, that is 1, 2, 3, 4. So these are the 4 carbon atoms that are being attached towards the main hydrocarbon, that is decane, but I'll name this as to be 1, because this is the group that will be attached towards the parent hydrocarbon, or we could say for decane. So suppose if this is the first one, this is the second, this is the third, and this is the 4th carbon atom of the side chain. And in this case what I have got to know, that at second position ethyl group is been attached. So the second position consists of ethyl group, so I could write this as C2H5. So now this is the thing that we have to make, and since this will be attached to the decane, so therefore this would be considered to be as H2. While filling the valency, this would be H, this would be H2, and this one would be at the outermost, or we could say that it would come at the last one. So therefore this would be basically CH3. So this is the group that we have to attach at 5th position, and at 3rd position we have to attach methyl, and again on 3rd position we have to attach methyl. So therefore at 3rd position there are basically 2 methyl groups that are being attached. So now let us do it carefully, and let us see one by one. So this is the decane that we have. So first of all, the thing that we are going to do is we are going to number it. So let us number it. That is, I'll number it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The numbering is very important because if we number it first after writing the whole parent hydrocarbon, and we'll number it first like I have did. So after that, the step that would be involved is to attach the substituents. So now easily I could attach the substituent at number 3, 4, 5 or whatever the name is being provided to me. So now in this case what I have got to see that I have got to see that at third position I could see a methyl group. So therefore for that I could make a methyl group that has been attached to the third position or the third carbon atom. So I could write it in this way, that is a methyl group. Again on third position is there again a methyl group is present, so therefore I would write it again CH3. So the two substituents are being filled, and because there were actually 3 substituents, that is this substituent was consisting of methyl, again this position or locate was consisting of methyl, and at 5th position basically the 2 ethyl butyl group is present, that is this group is present where the attachment will be from here, that is from CH2, and continuous we would write this as a side chain. So now this could be written as at number 5th. So the number 5th will have the side chain which would be written as CH2, that is we'll write this one CH2, then C, and here it was C2H5, or we could also elaborate it in the form of CH2CH3. So now let us fulfill this one. So this is how we have drawn the side chain. So this is the side chain that we have drawn, and or we have represented. So this is the thing that is done, but this is not complete. Why? Because as you could see that the hydrogens, the valency of the hydrogens are not been filled. So we have to fill the hydrogen valencies also. So for that it would be very much easy to fulfill. Like this one. Suppose if this carbon atom, as each carbon atom consists of its 4 valency, but in this case the 4 valencies are not fulfilled because only one, as you could see that only one valency is being maintained between this carbon and this carbon. But where are the 3? The 3 will be for the hydrogen atoms. So therefore I could write it as CH3. And in this case, because this is the carbon atom that has been attached to 2 other carbon atoms and making the valency of this to be 4, but carbon usually carbon has the valency of 4, but what would be the rest atom? The rest of the atom would be hydrogen itself. So therefore I could write it as H2. Again similarly here would be also H2 that would be present, here also H2, here also H2, and what about this? This is actually a tertiary carbon atom. So as we could see that this carbon has been attached to this carbon atom, again this carbon atom and this carbon atom, so making the valency to be 3 right now. So how it would be maintain the valency of 4 unless it will attach with the hydrogen, because we are talking about alkane. So now this would be written as H in this format. Again this is carbon is maintaining the 2 valencies right now, but originally a carbon has a 4 valency, so therefore we could write it as H2, and in this case no hydrogen is required because this carbon atom is already fulfilled with its valency. So no need to write the hydrogen here, and we could write the hydrogen 2 as well as here, and this is the sense that it is the primary carbon atom, because here also it was the primary carbon atom. So it will consist the hydrogen atoms to be 3. So this is the structural formula of the name that was been provided to us, and it is very much easy to understand. Or we could either do a cross checking. How? Suppose if we have drawn a from a name to we have drawn a structure. So just as to confirm and just as to make us very much able to write the IUPAC name, so we could give an IUPAC name to this also, and again this would be the same as the given question that is provided to us. So it is very much simple to understand. So this was the first one that I presented in front of you. So let us move on to the second one. So now this is the second IUPAC name that has been provided to us, and for which we have to draw the structural formula. So let us understand this name. So this name is nothing but that is 5 secondary butyl 4 isopropyl decane. So in this case, as I have said earlier also, that we have to just observe the suffix of the name, and in this case the suffix of the name ends with decane. and since it is ending with decane, that decane will represent the total number of carbon atoms that are present in a straight chain or in continuous chain, or we could also say it as the parent hydrocarbon of the alkane. So now this thing is having a name of decane, so therefore there would be basically 10 carbon atoms that would be present in a straight continuous chain. So that is very fine to understand. But what are the substituents that are being attached to this parent hydrocarbon? So the substituents that are being attached to this hydrocarbon is basically secondary butyl and isopropyl. And isopropyl is attached to the 4th position, while secondary butyl is attached to the 5th position. So before substituting this substituents in the main chain that we'll draw in that method, so we have to first analyze that what would be the structure of secondary butyl and what would be the structure of isopropyl, and then only we could with the help of that we could easily substitute the value as a side chain or as a substituent in the parent hydrocarbon, that is decane. So let us introduce first of all that how can we write the secondary butyl structure. So therefore, because it is a secondary butyl structure and the secondary itself means that the carbon will be attached to 2 carbon atoms, and moreover it has butyl, means overall the carbon atom would be basically 4 carbon atoms. So how can we write that? I am talking about right now for secondary butyl, because secondary butyl is the one which will consist of basically 4 carbon atoms overall. So this is basically the 4 carbon atoms. So this is basically the 4 carbon atoms, and as I could see that this here I have saw that is secondary. So secondary means that is it will be attached to means the attachment will be from the second carbon which is itself a secondary carbon atom. So the thing that I am talking about is, suppose if I am choosing this carbon atom, so this carbon would be called as the primary carbon atom because this carbon atom has been attached to one carbon atom directly, and as well as this carbon also, this carbon is the one which is attached to one carbon atom, making this to be the primary carbon atoms. These two are the primary carbon atoms. But talking about this carbon atom, this atom is being attached to 2 carbon atoms, so that's why it is basically the secondary carbon atom, and moreover this is known as the secondary alkyl group. And we have also studied the alkyl groups classification, in which we have studied primary alkyl group, secondary alkyl group, and the tertiary alkyl group. So now we have made I have drawn it with a writing so as to justify or so as to make it clear that the bond attachment will be from the second carbon atom of this butyl group. So now this is basically the secondary butyl. So but it is not been fulfilled, so we have to fulfill the hydrogen atoms also in this case. So for that, since this is the primary carbon atom, so therefore it will be CH3. Again, this is the primary carbon atom, this would be CH3, but here the number of hydrogen atom would be basically 1. The reason behind that is 2 carbon atoms are occupying the valency of the carbon, and 1 will be occupied by the hydrogen, and while 1 which has been represented as in red line, that would be attached to the main parent hydrocarbon, that is decane. So now it has been fulfilled, but 1 is also remaining, that is for this one. So this carbon atom, since it is a secondary carbon atom, so therefore we could write it as CH2. So now this is the structure of secondary butyl, and this is what we have to attach over the decane when we write it in a straight chain or longest chain. So this is the one that we have drawn for butyl. So let us think for isopropyl also. So the name itself is isopropyl, and isopropyl is the one that we know in, and we have did in our previous lectures also. And the overall carbon atom that it would contain is basically 3, because it is having a name as propyl, and propyl means the one which has 3 carbon atoms when it comes to alkane, and more 1 hydrogen will be less in that case. So therefore in this thing basically methane, ethane, propane. If I fulfill H3, H2, H3, then this would be propane. But since we are talking about propyl, and moreover it is not N-propyl, because it is represented as isopropyl, means the thing is we have to represent in such a way that the attachment will be from here. Now this is called to be isopropyl, because we will write here as CH3, here as CH3, and this would be CH, and now the attachment will be from here, making this to be called as isopropyl, not N-propyl. So that is the main thing, and that's the reason the previous lecture that we have did for alkyl groups was very necessary, and that's the reason we came up till here. So now this is what we are going to attach over the fourth position of the decane. So these are the groups that we have made, and we have made a structural formula in this case also, and this is what we have to substitute. So let us move on towards the first thing, that is for decane. So now the thing that we have to do is we have to draw the structure of the decane. So we are not going to fulfill the hydrogen, but we are going to draw the skeleton of the carbon atom. So let us draw the straight chain of the carbon atoms only. So therefore there would be basically 10 carbon atoms, because it is a decane. So therefore I will name it as 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is the 10 carbon atoms that are been in a straight chain, and moreover what we have to do is we have to number it, because numbering is also very much essential. Suppose if I have named it as 1, 2, and if I am substituting the a group or a side chain in the second carbon atom, and meanwhile for talking about the another group, suppose it is fourth, it is been attached to the fourth position, I cannot take it from here as 1, 2, 3, 4, and I cannot attach on this as to be the fourth position. So that would be very much wrong. So that's the reason that what we have to do is we have to number it first, so therefore we would be in a safe zone, that we won't get a mistakes while writing the name or while giving the structure of a particular name. So for that, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9th and 10th carbon atom. And in this case, only the thing that we have to do is we have to substitute the side chain or the substituent that we had. So the substituent that we had was, these were the two groups, that is one was secondary butyl and one is isopropyl. But talking about that is the secondary butyl is the one which has been attached to the fifth position. So now in this case what we are going to do, we are going to attach this group at the fifth position, and that would be, so the fifth position will have an attachment. So this is the carbon that would be attached towards the parent hydrocarbon, and that is this one, that is the red line that you are seeing. I have prepared the bond here itself, and I am going to fulfill this all values or this all carbon atoms. So therefore this was CH that I got, and I have attached CH2, again CH3, and here also I have attached CH3. So this is the group that I have been attached towards the fifth position of the decane, or fifth carbon atom of the decane when it comes to the IUPAC nomenclature as well as numbering. So the fifth is done. Talking about the fourth, at the fourth position it consists of isopropyl, and this is the structure of the isopropyl. So this is the structure of isopropyl that I will insert in the decane. So it would be, and that is also been attached towards the fourth position. So therefore, since suppose if I don't have space, I could draw here also, just for an instance. So I could write in this format, that is CH, CH3, and here it was CH3. So this is the same group that has been I have drawn over there. So now the substituents and the hydrocarbon, the longest chain of hydrocarbon, the both all are done, and the last thing that is remaining is fulfilling the hydrogen atoms. So let us fulfill the hydrogen atoms. It would be very much easier to understand. Talking about the primary carbon atom, this is to be the primary carbon atom, and it would consist of CH3. Again, this is the primary carbon atom. Again, this would be the CH3. And talking about these two carbon atoms, so this would be basically the secondary carbon atoms, and secondary carbon atoms consist of H2. Here also I could write it as H2. While talking about this carbon atom, because this carbon atom is basically the tertiary carbon atom, as you could see, because it has been attached to three carbon atoms, that is 1, 2, 3. So therefore, fulfilling the valency of the carbon atom, I have to provide an hydrogen to that. So therefore this would be a hydrogen, and for this again a hydrogen will be there. So fulfilling this is very much easy, and the only thing that we are required is to understand whether it is a primary, secondary or tertiary or an alkyl group. So based on that we could fulfill the hydrogen atoms, and here also it would be H2, and here is also H2. So this is the structure of so this is the structure of the IUPAC name that was been provided to us, that is 5 secondary butyl 4 isopropyl decane. So it is very much simple, and let us check once again also whether it is following the IUPAC rule or not. So suppose if this is the longest chain that they have provided, and suppose if we have wished that there would be possibility of another longest chain and with more substituents. So suppose if I number it from 1 2 3 4 5 6 7 8, so this is the value that I have got as 8. So 8 hydrocarbons atoms are in a straight chain, that's fine, but there is also a longest chain that we have, that is this one. So this is the one that has longest chain. So therefore we are maintaining the IUPAC rules and we are obeying the IUPAC rules, and by this we are giving the structure to the name that they have provided to us, or to any name that is given to us. So this is the thing that we have did, a bit of easy one. So let us try the another one, and let us see the different kind of the structure that we will observe, or that we will make by just observing the common by observing the IUPAC name that is been provided to us. So the third one is, so this is the third one that we have, and we have to draw the structure of this thing. So let us understand what would be the parent hydrocarbon. Again, the name itself, we have to just observe the suffix, and in this suffix I have got to know that it is nonane. So nonane is the one that a hydrocarbon which consists of basically 9 carbon atoms, and this would be the parent hydrocarbon, or the carbon atom that would be in a continuous long form or a long chain. So this would contain basically 9 carbon atoms, and let us understand that what are the substituents that are being attached to this parent hydrocarbon. So they are basically methyl group, because, and that is also attached to the second position, and talking about this is the one which has been attached to the fifth carbon atom, that is, this is the side chain that has been attached to the fifth carbon atom. So let us draw the side chain first, and then we'll substitute. So it will be very much easy to understand, and we won't get any kind of error while writing the structural formula of a given IUPAC name. So let us start with this structure of the side chain. So now the side chain is consisting of a name that is 1, 2 dimethyl propyl. But what is the suffix of this name? It ends with propyl. So therefore the main chain, or the longest chain of this side chain, would be basically propane, and propane means the one which has 3 carbon atoms. So therefore I would write it in this format, that is for propyl. So this is 1 2 3 carbon atom representing propyl, and moreover I could see that at position number 1 and at position number 2 there are methyl groups. So therefore I could write it as here as methyl groups. So suppose this is the first one, first carbon atom of the side chain, second and third. So at first position there would be methyl group, and again the second position there would be methyl group. So making the overall side chain to be called as 1, 2 dimethyl, means 2 times methyl, and the overall side chain consists of a longest chain known as propane, or basically we could say, because this is an alkyl group, so we will name it as propyl. So we have to fulfill the valencies also. So therefore this is the last carbon atom, or we could say as the primary carbon atom. So now therefore it could be called as CH3. And talking about this is a tertiary carbon atom, so making this to be called, have a hydrogen atom as 1 hydrogen atom. And talking about this, again this would be called as the tertiary carbon atom, because this is the carbon atom that will be attached to the main parent hydrocarbon, so making it an overall to be called as the tertiary carbon atom. So that's the reason we have attached here H, and we have not attached here as CH2, and meanwhile we need a group or we need an attachment that would be for the nonane as a side chain. So this would be the attachment of this group with the nonane that we have as a parent hydrocarbon. So this is the group that we have made for this one, and let us talk about what else is the group, or what else is the substituent that we have. So that is methyl, and methyl is nothing but CH3. It is very simple to understand, and so let us do, this is the 2 that we have got, and the main thing that we are going to do is we are going to write the or draw the structural formula of nonane without hydrogen representing here, because I know that, and we know that the hydrogens will be full based on the valency that it has. So now let us draw for the nonane, and for that nonane is the one which consists of 9 carbon atoms. So therefore this is 1 2 3 4 5 6 7 8 9. So 9 carbon atoms are in a straight and a longest chain, and in this case basically on the 5th position that I could see that in 5th position this group is been attached. So this group should be attached on the 5th position. So let us draw this as a side chain on the 5th position. So this is the group that we'll draw on the 5th position, and meanwhile the methyl should be drawn on the 2nd position. So therefore starting with the 5th position that we have, and but we have not named it. So the first thing is we have to number it first. So this is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th and 9th carbon atom, and talking about the substituents. So at the 5th position this group is the one that will be attached over there. So therefore at 5th position the group that has been attached, or the substitute, the side chain that has been attached, is basically CH3 in this case. Again down here that is CH3, and here also there would be CH3. So this is the side chain that we have drawn, and but this is the one that has been attached to the 5th position. And what about the second? And the second one consists of basically a methyl group, that is CH3. So the work has been done but not complete yet, because this is the main thing that we are done, and because of which the IPC structure has been drawn over here, and now we are going to fulfill the hydrogen atoms. So for that we know that this is the primary hydrocarbon atom or primary carbon atom. So therefore I'll leave it as CH3. Again this is the primary carbon atom to be called as to fulfill the hydrogen as CH3. Here it is tertiary, so I'll limit it as H. Secondary, so as H2. Here also it would be H2. Here it would be H because it is a tertiary carbon atom, H, and here would be CH2, and here also will be CH2, CH2. That is methyl, methylene and methine, the one which consists of A1 hydrogen. So these are the group that are being given to us, that is CH3. When it comes to CH3 it is known as methyl, when it comes to CH2 it is known as methylene, and when it comes to CH it is known as methyl. So this is what we have we are going to study also in our future, and so this is the thing that we have drawn for the 3rd IUPAC name that was provided to us. So now let us move on to the next one, that is for the 4th one. So this is the 4th one that we have, and we have to draw the structure of this IUPAC name. So this would be very much easy because this doesn't contain a huge side chain that in earlier 3 cases that we have mentioned, and moreover we could see that it would be very much easy and we not complicated, as there were 9 or 10 carbon atoms that were in a straight chain, but here it is comparatively less. How? Because as the suffix says that it consists of pentane, and pentane is the one which consists of basically 5 carbon atoms in a continuous long chain, and we could write that first also. So in this case we don't have to write the substituents early because it is very much easy, because ethyl is present and methyl is been present. So we could directly write pentane to be called as the straight chain 1, 2, 3, 4, 5. But still numbering is very much important, so we'll number it first as 1, 2, 3, 4, 5, and then we could add the substituents. So in this case basically on the 3rd position we could see that ethyl group is been present, so I would write it here as C2H5 or CH2CH3. That is the thing that we could write, and moreover on the 2nd position I could see that the methyl group is been present, but on 2nd position 2 methyl groups are been present. So therefore this would be CH3, that is for methyl, and again on the 2nd position methyl is been present, so making it to be having 2 times or di times CH3. And now most of the work is done. Only thing is been remaining is to fulfill the hydrogen atoms or the valency of the carbon atom. So we'll fill it by H3, here also by H3. No need to fill the hydrogen because the carbon atom is fulfilled with its valency here in this case, and now I will fill it here as CH, and here will be at CH2. Very simple. So this one was the simple one, and I didn't made this to be the first thing because as the first IUPAC name to convert into its structural form now, because the one that we have did earlier, that was that could be a bit difficult, or that could be a bit complicated. So to understand that was very much important, and this is now very much easy because we have did that. So now this is very much easy for us. So now let us move on to the next one, and for next one what we have this one, that is 3-ethyl 4-methyl hexane. So I know you have got an idea that how to write the IUPAC name or the structure, and since the suffix is ending with hexane, so hexane is the one which contains 6 carbon atoms when talking about a hydrocarbon, especially for alkane. So these are the 6 carbon atoms that are been present in a straight chain or in the longest form. And in this case, what we have to do is we have to attach the substituents, and the substituents are basically ethyl group and methyl group. But the ethyl one is the one which is present in the third position, so we could write it as but numbering is also very important. So what we are going to do is we are going to number it. So this one would be the first one, second, third, fourth, fifth, and sixth. And now I could substitute the values without any fear or without any confusion. It would be very much easier to substitute the values like or substitute the groups like we have as ethyl and methyl, and the ethyl is been attached on the third position, so ethyl can be written as CH2 CH3, or basically you could write it as C2H5. And on fourth position it has been known as methyl, so methyl group is been present on the fourth position. And just fulfill the hydrogen atoms, so this is the primary carbon atom, so make it as CH3. Here it will be also CH3, while here it will be CH2, and here also it will be CH. Here it will be CH because of the tertiary carbon atom that we have did in earlier IUPAC name, and we have converted it into structure form. So in that case also we have did that, and now in this case, because this is a secondary carbon atom, so for balancing the hydrogen atoms, we fill it by 2 hydrogen atoms. So now this is the structure that we have drawn for the fifth IUPAC name that was being given to you. And moreover, the thing that you have observed is even though if you have numbered it this to be 1, 2, 3 and this to be 4, so the third one would have been gone to the methyl, and the fourth one would have gone to be for the ethyl. But the IUPAC nomenclature that we have did, or the rules of IUPAC nomenclature that we have did, so in that case what we have learned that the numbering will start from that end of the carbon atom where we could see that the substituent will have an alphabetical order. The substituents will be in an alphabetical order. So as we could see that if we move from left to right, and if I name it as 1, 2, 3 in that manner, so I could see that ethyl is the one that is having a preference or a prior alphabetical order compared to that of the methyl, that it starts with M. So that's the reason numbering has been start over here. Or we could say that we have named and we have numbered the carbon atoms, and we have substituted the values at the correct position, that is at 3. So we could see that they are following the IUPAC rule, and we have to also follow the IUPAC rule. It is very much easy to understand. So for this, the main thing that I will suggest you to just know that what are the IUPAC rules of nomenclature for an alkane. So this is how we have did. So there are more kind of things that we are going to do, that we could be able to do for nomenclature of this alkanes. So thank you friends for watching this video. So this is very easy thing to do. So I hope you will do this also, and you'll try to do more and more structural formulas for the IUPAC names, and it will be very easy for you to do for an alkane. So thank you friends for watching this video. I hope you have liked this video and you have understood that how to draw the IUPAC structure or the structural formula for an IUPAC name. So share this video with the friends, and just don't forget to subscribe Ekeeda channel. Thank you so much.